Okay, so I want to move on from my initial projection setup, which I did in Nuke, using these nodes, using this library that I created for these tests. I want to move on from this and project onto a piece of 3D geometry rather than onto a flat 2D shape as I was doing before with the card. So I've left the card there, but I won't actually be using it for this demonstration. Okay, so the premise of what I'm trying to achieve here is that a single projected image, which in this case is going to be my checkerboard, it'll only achieve partial good coverage when it's seen from a moving camera. As the moving camera moves away and starts to move out of the range of the projection camera, then what I should see is I should see the texture begin to fail in some way. Okay, and this is one of the reasons why I'm using a checkerboard, because we have this very geometric pattern. We should be able to see any degradation of the texture as it projects and as we start to reach the limits of the projection. Okay, so what I'll be looking to do beyond that is extend, or should I say improve, the quality of the coverage by adding a second projection. Okay, so I'm going to start by creating a projection setup as I've done before. So I'm just going to select these nodes. Whoops, I don't want to do that. In fact, that's a bit odd that that is happening. So I'll just dock this. Okay, so they will appear in that panel rather than just appearing in an open window floating in the viewport. Okay, so I'm going to start by constructing a node set. So I'm hitting Control-C to copy those, and then I'm just moving down here, Control-V to paste them. As I said, I'm going to project it onto a 3D surface rather than a flat 2D, so I'll delete the card. I won't use it in this particular example. Okay, so now I just want to go ahead and quickly reinstate the basic camera projection setup that we've had before. So essentially we have our shader, we have a projection camera, and that projection camera will project this material onto this 3D surface. So if I hook up now, we can see that in operation. We can see some slight weirdness here, which hopefully I shall be able to explain later on. And we can see the projection camera here. Okay, I'm going to hook up my scanline renderer and then hook up the shot camera, just purely and simply so the rig is complete. Okay, if I scrub through now, we can see the animation that was on the shot camera from before. So if I just double click the shot camera so we can see it more clearly in the viewport, we can see how this pushes in from its original position. We can see, if I just come out here so we can see it, it pushes in from this position, pushes in close. That's where we'd left it off last time. Now in this particular case I want a different kind of animation on the shot camera, so I'm going to do something a little bit different with this. So I'm just going to zoom out so that I can see a little bit more of my space. Just come to the first frame, and what I'm going to do is I'm going to kill off the animation at this point, and I'm going to create some new animation. So I'm just going to right click in the shot camera and say no animation on all knobs, and that will delete. It'll obviously give me a nag to ensure that I can confirm that. So yes, and now the animation is deleted, but because I was on frame 1, then it has left me with the translation properties from there. Okay, so what I'm going to do on this first frame is I am going to set a key so it's reinstated there, and then I'm going to come to the end of the sequence and I'm just going to reposition this camera. Okay, I'm going to rotate it as well. It's not that easy to see actually. So just getting a little bit closer to that. I'm not convinced that that's a particularly good camera position that I've got established there. Okay, So I've got a 90-degree camera movement there, so we should see the camera moving. Actually, I haven't set my my key on the rotation, which was a mistake on my part. So I'm going to come back to the final frame and set a key on my rotation, and then I'm going to jump back to the beginning and just reset that to 0, which will automatically add a key. Now we can see that animation moving around. Okay, it's moving in a straight line. I'm just going to do something about that. So I'm just going to come into the middle. We start at frame 13. I've just got an in point there set. So let's say around about frame 55, and I'm just going to sort of position that a little bit, just to kind of create a little bit of an arc. Just make sure the entirety of the sphere is within the camera frustum there. And we can see there that it's set to 43. I could type 45 and just get that a little bit better. Maybe move it across a bit. Okay, so I've got 3 keyframes now, and I've got more of an arc, and I'm just looking to make sure the sphere stays broadly within the boundaries of the camera frustum, which it does. Okay, so if I just quickly jump back to my 2D view here, and then just play this out, and we can see the projection on both surfaces, both the inner and the outer surface of the sphere moving around. Okay. Alright, back to 3D. Okay, so this is my shot camera, and the way that I'm going to approach this coverage is basically to create projection cameras from the path of this shot camera. So I've got this camera up here, which I'm actually going to delete, and I'm going to create a new shot camera from my first frame. Okay, so I will copy this, edit, copy. I can't be bothered doing that all the time, so I'll use Ctrl V to paste it. So this is my first projection camera that's on frame 13. So I'm going to call it projection camera 13 to denote the frame that it's on. Okay, while I've got it, I'm just going to pick a colour just to differentiate my projection cameras from my shot camera, and I'm going to hook that up to my shader. Okay. Now one thing I'm going to do just quickly is I'm just going to set my projection to the front, and I'm going to come back to that later on and explain a little bit about what that's doing. But anyway, for now we'll just leave it at that. If I switch back to my scanline renderer and drag this forward, we can see some weird things are going on. Maybe better off seeing that in 3D. We can see that my projection camera is animating, and that's because I haven't disabled the animation. So I need to make sure that on my first frame, in this case frame 13, I just need to make sure that I clear the keyframes but retain the initial property. So now we should see my shot camera moving around, but it's projecting onto the surface. Okay, so let's just get into this now and just take a little bit of a better look at this. You can see some quite interesting stuff going on here actually. Okay, so what we can see here is we can start to see the texture starting to smear and stretch as we start to get, as the camera and the shot camera starts to get further round. If I just take a look at this from the shot camera in the OpenGL view, we can see that as the camera moves further and further round, we start to see these tiles of our checkerboard starting to elongate, which means essentially that our matte painting is starting to stretch. We know that this projection will project onto a 3D surface, and basically it will stretch out to fill all the UVs in our geometry. Okay, so what's actually happening in this case is because the texture is starting to get out of view from the position of the shot camera, we can see this probably better from a top view. We can see that as this moving around, we're starting to get to the very boundaries of where the projection is ending, and so as a consequence of that, we're starting to see the smearing of the texture, and that's something that we need to address, because obviously in our matte painting this would represent distortion of our image, and clearly that's something that we need to overcome. So how we would do this would be by adding a second image which would cover this area of smearing. So this would be a second projection from a different position, or should I say a different position from the shot camera along this motion path. So if we come around here to frame 100, for example, we know that this camera is looking directly at this side of the image. So if we projected an image from this perspective onto the sphere, that would then cover all, if not all, most of this stretched area of texture. So let's do this. So while we're on frame 100, we will, I won't do that, I'll copy and paste. We will create a second projection camera, and I'm going to name this projection camera 100 after the name of the frame, or the number of the frame that I'm using. Okay, and then from that I'm going to copy those three nodes and just dock them here and just drag these down. I got the sphere by mistake, I didn't want that. And this is my projection camera. So as before, what I need to do is I need to clear the animation, confirm that, and even though I don't have to do this, I'll give it a colour so that our projections are differentiated from our shot camera. Okay. Now, if we look at our project 3D, if I hook that up to the sphere, you'll see that it quite happily accepts it, but it cancels it from this side. What this essentially means is that our geometry will only receive one shader. So we have to have a way of basically connecting these together before we reach the shader. And this is where this node comes in, which I will copy and paste down here. This is the merge material node, and this does what it says on the tin. It basically merges the material. So I'll connect them up. There is an A and a B pipe, and we'll come on to that in a second. I'll connect it up. I'll just hold down Control, just drag out this dot node just to keep my script nice and tidy. And I need to distinguish between our two checkerboards. So I'm just going to recolor some areas of this checkerboard. So I'll just see whether that's worked very well. That's adding some reds in there. I'm focusing on this graphic. Oranges. Okay, that's a particularly nice tartan. Okay, so we can see the checkerboard that's differentiated from our grey one. The two shaders each being projected from their own distinctive projection camera, which are at different positions along the motion path. They're being merged together, and then they're being connected to the sphere. Now, because this one is being projected from this side, we would expect to be seeing that at this in this particular area, and we're not. And the reason why we're not is because of the stacking order of our merge. Because at the moment we're using the merge paradigm, which basically is A over B. So essentially what it's doing is it's projecting the grey texture over the top of our new texture. So essentially what that means is that we need to reverse these. So I'll just disconnect, and I'll connect the A side up there and now the B side. And now we can see something different. We can now see the projection of our new checkerboard over the top of our existing one. By the way, just before I move on, Shift X quickly toggles the A and B, so we can quickly jump backwards and forwards by doing that, so we don't have to go through that convoluted process of disconnecting our pipes and reconnecting our pipes. So if we switch back into 2D and we look through our scanline renderer, and if we just scrub around this, we can see now that our new texture is providing the additional coverage to hide most of the offending smearing areas that were evident when we were only using this one camera. I mean, there's probably some evidence to suggest that, you know, I'm just looking here for example, maybe evidence to suggest that we may need to have an additional projection camera somewhere in the middle that's projecting a texture into this area, that's dealing with this little bit of additional distortion that we've got here. But the process would be the same. Essentially what we would do is that we would, I won't do this, but what we would do is that we come into the central area there, and we would create another instance of this shot camera as a third projection. We would replicate this scenario and this merge material and merge in again, and obviously we would replace the projection camera with a projection camera created from this particular position with the animation removed, and that would basically put a patch into this midway area and deal with any distortion that's created from that. Okay, I'm just going to come back to the first projection, and I'm just going to disable all this stuff so that we can see our first projection. And we can see we can see all this distortion that we had originally when the shot camera is actually seeing when the shot camera is getting looking at an angle where there's very little usable texture visible from the perspective of this projection camera. I just wanted to make a note about the projection surface, because we did I did mention this before. The Project 3D node has this property called Project On, and what this allows us to do is this allows us to determine the face of the geometry that our image is projected onto. So effectively what we can do is that we can determine whether the projection is front facing, is back facing, or is both. And again, if I just come out here, I'll just kill off all those just so that we're working with the right one. So if I set this to front facing, it basically means that the material is projected only onto the forward surface of this material. So the texture is only hitting the front surface. Okay. If I move around, we can see the back of this image is actually in darkness. This is actually an aspect of OpenGL. We wouldn't actually see this in the scanline render, but nevertheless it's worth you being aware of it, because we're no longer seeing the forward surface of the material, or should I say of the geometry. Then we stop seeing our texture. Okay. Similarly, if I set this to back, what's happening now is that it's projecting onto the back of the surface. So we can see now that the front of the surface has no material projected on it. The material is only being projected onto the inside of the sphere. We'll look at that again in a separate demonstration. And then if we have it set to both, then it projects onto both the front and the back faces. And to be honest, for the most of the time you can leave it at both, because as I said, some of these things that you see in the 3D view you don't actually see when you from the perspective of the scanline renderer. So from the perspective of the scanline renderer, the front perspective focuses just on the front, and that's essentially what we would want to see at this stage. On the back, which is typically what you might use, for example, for a sky dome, and then both, which looks very much the same as front. It's from this point of view. Okay, so let's replicate all this, and we'll look at what happens when we project onto the inside of a surface. So this is typically how we might approach. I'm just going to disconnect all those, or disable all those. Okay, so they're all disabled. Now what I want to do now is I want to show how we might approach a projection onto the inside of a surface, typical of what we might do, for example, if we were projecting a series of images to create a sky dome or a panorama involving a landscape. Okay, so what we would do in this case is we would set our Project 3D now to look at the back side of the image. As I said, as we come around the back side of the image, the OpenGL view will stop showing us any of the texture, because it's only visible, because the inside is actually only visible on from the perspective of this particular projection camera. It's only visible from this angle. Okay, in fact, I can delete that projection, because I'm going to need a different projection for this. Okay, so what am I going to do? To create a sky dome, we would have a distinct difference insofar as the dome would, let me just set that to something like 4.8, maybe 5. What I'm doing is I am basically putting the sky dome on the outside of my camera path. So my camera and my projection now exist within the boundaries of this sky dome. The reality of this situation would be that if we were creating this as a sky dome, then this dome would be huge, and all of our other projections, say for example we're creating an environment, maybe we were compositing some CGI or some green screen or some other effects, they would all reside within the boundaries of the sky dome. The sky would be the furthest away from our cameras. So with this particular setup, our cameras exist within the dome itself, and we can see our original projection there actually projecting onto part of the inside of the geometry. So if I come inside this now, so just click. In fact, I'll just click off the sphere, and we come into this. We come into this. We can see how this might represent the sky, and we can see our projector moving around. Would need to see different areas of the sky as it came around. So what I want to do is I want to add coverage to this, so that as the camera comes around, I just put this on the shot camera, and just lock it off. We can see this boundary here, this little sort of dotted line boundary. This represents the boundaries of the screen as determined by our project settings from the perspective of our shot camera. So we can see that we start off here with full coverage. This is our original projection. As we come around here, we can see that our projection starts to disappear off the edge. We can see that at this point it's gone off the edge. So what I'm going to do is I'm going to come forward to maybe about somewhere around about here, frame 57, 58, because within the boundaries of the screen I've got a little bit of overlap, and overlap is absolutely critical for projection, for coverage projection, because we do need this overlap to be able to blend images together. Okay, I won't be doing that in this demonstration, but we do need that little bit of overlap for that purpose. So around about frame 57, we've got we've got a little bit of overlap, but we've still got all this coverage area that we need to fill. So this is where I will copy my shot camera, and I will call this projection camera, and I'll give it the name of the frame, which is 57. Okay, so I'm going to reconnect these, hook these back up, turn them back on. I do need to set my project 3D node. Just need to make sure it's not projecting just on the front. I need to make sure it's projecting either both or on the back. I'll leave it on the back. I think this one is set to the back. Okay, and we can see now that we've got coverage. So we can see now that as this camera spins around, the problem there is that I haven't killed the animation on my on my second projection camera, so I'm going to need to do that. So it looks like I thought I created this camera at 57. I'll just delete it and start again for that reason. I'm not 100% sure. I'm just going to disable those. So I believe it was 57. 58 is getting a little bit tight in terms of coverage. Maybe it's okay. So we'll go with that. So I'll copy and paste, rename this projection camera, and append it with the frame, which is 58, and kill the animation. And I'll give it the projection camera color and re-enable these nodes and the merge material node. Now we can see the coverage, and hopefully, if we look at this from the point of view of the shot camera, now our second piece of sky is moving correctly. So whereas we only had coverage up until about frame 50, well, we only had coverage for a very small amount of the frame. Now we have coverage right up until frame 57, when we start to lose it again. So what we need to do now is we need to come as far forward to make sure that we do like we did before. We make sure that we've got some overlap. In this particular case, I've run out of frames, so frame 100 is going to be perfectly acceptable. So again, I'm just going to copy my camera, paste it, and this is going to be projection camera frame 100. Okay, I can't call it that. There is already one called that, so I'll just append it with an A because I'm not sure where that is. And again, I just need to clear the animation by saying remove animation from all knobs, and then set the blue colour with this. So the final step is to basically make a duplication of these nodes. So just select them, copy and paste. Okay, and then set that to B. So we're now stacking our merge nodes. And as a final step, I just want to take this checkerboard and give it a different colour. Again, just so that we can differentiate between our three checkerboards. So this is now projecting on frame 100. Hopefully it is. I'm not sure what I've done there. Oh, I do know what I've done. I've just not replaced it with my new projection camera. So we can see now that as this comes around, we've got coverage all the way to the end there. So this is typically how we would have coverage to a sky dome. Okay, I'm just going to flip into 2D and then play it out so that we can take a look at this. So we can see our second texture coming in at that point. We can see the overlap areas that we would need to blend, and then we can see our third area coming in. One thing they have noticed that we can see here at the joins, and again at this point at the joins, we can see a little bit of loss of coverage, which is essentially caused by the size of the projection, essentially. Because of the perspective, it's not filling the screen, so we've got a loss of coverage in these areas. I'm not going to deal with that at this moment in time. I'm going to investigate ways or best methods for actually addressing that. There are 2 or 3 potential ways that that could be done, so I'm going to investigate those methods and maybe explore those different methods using a test sequence in the future. Okay, but I'm going to wrap up for now with this. I've personally found this to be an interesting and productive experiment, and I hope that you found it both useful and informative.